For number one, we need the area of a square that is 10 millimeters on each side. So to find the area of a square or a rectangle, it's just length times width, or base times height, whichever way you want to think about it. Okay, length times width, the square is going to have the same length and the same width, so it's basically going to be 10 length times 10 width, which is going to give us an area of 100 square millimeters. Alright, for number two, we got a rectangle, and we know that the short side is 6. They already give us the area, which is 120. So with our formula here, we know that the equals should be 120 because that's what the area is. The width is going to be 6 because that's the short side. And then we've got the length. So we just need to figure out basically what times 6 equals 120. There's a couple ways we could do that. We could just do the opposite of times by 6 and divide this by 6. We could go 120 divided by 6. 120 divided by 6 is just simply 20. Okay, you could kind of guess and check your way up. Let's say you thought this was 10. 10 times 6 is only 60. Maybe 15. 15 times 6 is only 90. Go up to 20. 20 times 6, it is 120. So you're definitely going to want to use 20. So the answer to this question is the length of the rectangle would have been 20. Alright, for number 3, if you didn't notice in the corner that it's got this 40 by 40 square that kind of tells you the lengths of each side, don't worry about it. I'll explain it with both here. Don't worry about this for now. All I did for this diagram was I went through and I counted first the full squares. Okay, and your answers may slightly vary from mine, but it should be about the same. I mean, it really should be pretty close. I counted 34 full squares, which means that's an area of 34 right there. Okay, now I counted 12 half squares. Okay, now if I put half squares together, it takes 2 half squares to make a whole square. So if I wanted to change this number to whole squares, every 2 is going to be a whole square. So every 2 here, so that would be 6 whole squares I can make out of 12 halves. It's almost like having a mixed number. 12 halves is what I have. 12 halves changes to 6 wholes. Okay. Now, here's the ones you may have called half, or you may there's one in there that's like it's more than half. So I just said 3/4. There's one in there that it's less than half, so I just said 1/4. Okay. If you combine a 3/4 and a 1/4, 3/4 plus 1/4 is another whole. So I'm just going to put another whole there. Okay. So now if we add these up, 34 plus 6 would be 40, 41. So if you had an answer about 41, that's fine. Okay. Now, if you took it a step further and you notice that each square was 40 by 40, which would give us 40 times 40, which would be 1,600. Okay. So each individual square, because it's not drawn to scale, so they give you that little 40 by 40 on there. Each square is actually 1,600 for an area. So actually you could do 41 times 1,600 and get an area of 65,600. So if you just counted how many boxes there were, you would have ended up with about 41, which is fine. If you went a step further and you know that each square represents 1,600, then if you multiply these two numbers together, you should get somewhere around 65,600 for your area. Either way is okay though. The picture of that triangle comes on that grid. Okay? And I just filled in the numbers and counted how many spaces the base and the height would be. Now, the base would be the bottom here, and the height's going to be from here to here. This clearly makes a right angle. It's perpendicular. So we can do this for base, this for height. So now we just have to use our formula. Base times height is going to be 7 times 4, which is going to be 28. That would be if it was a rectangle or a square, but remember, since it's a triangle, and triangle is half of a rectangle or a square, we need to cut that number in half. So if we divide by 2, our final answer is going to be 14, and then it's going to be square units or whatever our unit of measurement is, but it's going to be 14. All right, here's one of a million examples we could use here, but example that would show what kind of a fence is going to give you more yard is basically what we're saying, or give you more space on the inside. If I had to choose, and I'm looking at both of these options here, okay, I got a square fence that's 6, I don't know, we could say 6 yards on each side. That would make sense, kind of. We have a rectangular fence that's 10 yards on the long side, but 2 yards on the short side. If you notice, it's going to take the same amount of fence to build both of these. Okay? If I add around all the sides here, that's 24. If I add around all the sides here, it's also 24. So make no mistake, these would cost the same amount to build. Okay? Because we got the same amount of fence here as we have here. Now the difference is which one's going to give you more space on the inside. Here, if we're doing 6 yards by 6 yards, the area of a square is just length times width, just like we'll be over here. 6 times 6 is going to be 36. So that's going to give us 36 square yards to work with, which means that we can fit 36 squares that are a yard on each side. Over here, if we do the length times the width to find the area, that is just 10 times 2, length times width, which is going to give us an area of 20 yards squared, square yards. So if you think about it, we've got the same amount of material. You paid the same amount for this material as you did for this, or this fence as you did for this, because it's the exact same distance around the outside. But because of the way you shaped it, this is going to hold or give you 36 square yards to use inside of your fence. This is only going to get you 20 square yards to use inside your fence. So it clearly would be a better deal to build a square fence as opposed to a rectangular fence. Alright, for number 6, we just need to fill in the blanks. For our circle, we've got a diameter of 10. Okay, so our diameter is all the way across. Radius is halfway across. So the radius should be 5. Okay. Now our area of a circle is radius to the second power times pi. So my radius here is 5 to the second power times pi, which we're using 3. And we've always used 3. 5 times 5 would be 25 times 3. 25 times 3 is 75. So our area is going to be 75. Alright, the goat is back. And he's still chained up to the same thing. Still has 30 feet to work with. Okay, from the middle, from whatever he's tied to. And he's got free rein to walk around the outside as long as he's still attached with this. You'll remember the last time we did this question, we wanted to know how far around could he walk, which is the circumference. Now we're going to see how much grass does he have to eat in here, inside of the circle. Okay, so in order to do that, we need to do the area of a circle, which is pretty easy. Area of a circle is just radius to the second power times pi. So the diameter we could do, I mean, we know it's 60 because it's all the way across here would be 60. We don't really need that anyways. The area we need, that's how much grass is on the inside here for the goat to eat. So we just have to kind of fill in the blanks here. So we have 30 to the second power, 30 is our radius, times pi. 30 times 30 is 900. 900 times 3. 900 times 3 is going to be, what is that going to be? 2,700. So he's got 2,700 square feet of grass to eat. So you can kind of think about this really. If you look back at the back where that square foot is, that means that he has 2,700 of those square foot of grass to eat.